when we have a linear regression time series model, then as long as we can assume that the explanatory variables are exogenous and our data is stationary, the OLS estimator will be consistent and unbiased, and it will be so even if we have autocorrelation and or heteroskedasticity. It will not be efficient anymore, but the main problem with autocorrelation and heteroskedasticity is the fact that the standard errors will no longer be consistent. So the simple way of handling autocorrelation and heteroskedasticity in such a case would be to keep the OLS estimators of the parameters, but to adjust the standard errors, replacing the OLS Gauss-Markov standard errors with robust standard errors. And that is what this lecture is about. So the setup of this lecture is that we have a simple static time series regression model. All data is stationary and the explanatory variables are exogenous. But the other two Gauss-Markov assumptions, they might be violated, so the error terms could be autocorrelated or heteroskedastic or even both. If I look at this data where we have help wanted index and I'm explaining that using unemployment, so I'll do a simple OLS, help wanted index, okay. Now this is a static model, probably too simplistic for UN to be exogenous, but still, just to illustrate the idea, if I do a Bruch-Godfrey test for autocorrelation, then I can easily see that no autocorrelation is rejected. We do have autocorrelation, and the conclusion that I have to draw is that if I'm willing to assume that unemployment is exogenous, then these estimates of the constant and the marginal effect of unemployment will be unbiased and consistent. However, due to autocorrelation, I cannot trust the standard errors. They will not be consistent estimates. So what we can do in this case is that we can try the robust standard errors. And under certain conditions, these will be consistent. To get the robust standard errors, all you need to do is to do ordinary least squares and then click on the robust standard errors. The default setting in the case when Gretel has discovered that the data is time series data is the robust standard errors called HAC, which stands for heteroskedasticity and autocorrelated corrected standard errors. If you click on this HAC, you can actually change the robust standard errors that Gretel will use. It has these ones are available to you, and you can look up in the Gretel manual to see exactly what the difference between these robust standard errors are. This is the most common one and therefore the default choice in Gretel. So by selecting robust standard errors, clicking OK, you can see that there has been a significant increase in the standard errors. And that's typically the case when you use robust standard errors. You will end up with larger standard errors compared to the unadjusted ones. To get robust standard errors in eViews, you just go to Options and you go HAC, and this is also called New West. For HAC, you have some additional options also in eViews. So the most popular robust standard errors dealing with time series data are the ones that are called New West standard errors, or sometimes called HAC.